In the last lecture of the perturbation theory, I have derived these two equations. So today we will derive the second order energy eigenvalue. In the first lecture, I have derived first order energy eigenvalue and first order energy eigenfunction. I have used the first equation, but today we will use the second equation. So let's begin. At first we will write the taking inner product of equation 2 with, in the broad notation, psi n 0. So the equation number 2 becomes psi n 0 h 0 psi n 2 plus psi n 0 h dash, which is the perturbed Hamiltonian, psi n 1 equals to, in the right hand side, psi n 0 e n 0 psi n 2 plus psi n 0 e n 1 psi n 1 plus, for the last term it will be same, e n 2 psi n 0. So as we know that for the unperturbed Hamiltonian, if it operates with any eigenfunction, it gives the energy eigenvalue E0 with the eigenfunction. So here we will apply this rule. So it becomes psi n 0 E0. Here we can write en 0. So here it is also en 0 psi n 2 plus the second term remains same because of it is perturbed Hamiltonian. So after that, en 0 is just a number, so it comes out from the notation, Bryant curve notation. For the second term of the right hand side, en1 also a number, so it comes out from the Bryant curve notation. It becomes 8. And after that, for the last term of the right hand side, en2 also, the energy eigenvalue, it's just a number, so it comes out from the notation. So after that, here the first term, as we know that the en0 also the just a number, so it comes out from the Bryant curve notation. The second term will remain same. And here, as we know that for inner product rule, if the different states are present, the inner product will be 0. For the different states of eigenstates, different states, inner product will be 0, and for the same state, inner product will be 1. So after that, here the term, the last term will en2 will be here, and here the for different state of the inner product of different state will be 0. Then en2 equals to psi n 0 h dash psi n1. And as we know that psi n1 is the first order correction to the energy eigen function. So we have derived in the last lecture. I will recommend for the new viewers, please check out my channel and see the last lecture of the perturbation theory. After that, this video will helpful for you. Okay. And in1, it can be written as k not equals to n ck n psi k 0 in the gate notation. Okay, here we have derived in the last lecture Kn will be summation k not equals to n psi k naught psi k h dash psi n 0 by en 0 minus ek 0. Okay, so we will write the value of psi n 1, then it becomes ckn psi k 0, and we can write this equation. Here we are taking the summation out from the Bryan notation, so it becomes ckn k not equals to n, and here if we write the value of ckn, so it is, I am taking the summation here, and it becomes psi k 0 h dash psi n 0 by en 0 minus ek 0. As we can see here, the two terms in the denominator, so as we know that psi star psi equals to mod of psi square, we know that this is the fundamental rule. So after that, there are the two terms, this term and this term. Look at the two terms very closely and carefully, then you can see that psi n0 in the Bryan notation, and here the psi n0 is the code notation, ket notation, and here psi k0 is in the ket notation and psi k0 is the Bryan notation. So we can say that the right term is psi and it is psi star. So we can write summation of k not equals to n. So it is, we are taking it is psi as a psi, so we will write psi k 0 h dash psi n 0 mod square by en 0 minus ek 0. This is the second order correction of energy eigenvalue. So thank you so much.